Although it is straightforward to use Kto to build your backend application or REST service, right? But there are other frameworks that you can use to build your backend application, especially if you're a Java backend developer. It is most likely that you are familiar with Spring Boot. So we can use Spring Boot and Kotlin to build backend application, and that is exactly what I want to show you in this video. In this video, I'll take you through the process of building a very simple CRUD operation using Spring Boot and Kotlin. So if we go to the official site of creating your Spring Boot application, right? For the project bit system, we'll select Gradle Kotlin. For the language, we'll select Kotlin. Then we're going to add a dependency that will handle our endpoint, REST endpoint for us, which is Spring Web, right? Simple. Then for group, I'll change this to Jante Adibowale, right? For the artifact, this should be Spring API service, right? Then for this, we're going to use the embedded container, which at the end of the day is going to be Apache Tomcat, right? Because if we use Y, it means we're going to install a different application server. We don't want that. So we'll leave this at Java. For the Java, I'll leave Java 17, though it's always advisable to use the most recent Java, but for this I'm going to use Java 17. So I'll generate this and import it to our IntelliJ, then I continue from there. So I've imported the project, then I've also created different packages, right, to handle different layers of our backend application. We have the service layer, we have the repository layer, I have the model that will transfer data from the service layer to the repository layer. Then I have data transfer object. This will handle data coming from the client to the server, right? Good. But before we get to all of this, let me take you through this Spring application class. So for the Spring application class, right, this is our class. This is just a class in Kotlin. You can actually have it this way, the way you have it in Java. We can have it this way, but since it has an empty body, there's no need of having that parenthesis there. Then for this, this is annotated with Spring Boot application. So this is the application we'll run, right? This is the main function, which is the entry point to our project. So this function will directly run this class, which has been annotated with Spring Boot application. So if we drill down to this function, as you can see here, this function is basically an inline function, right? That taking a generic type of this referred generic type means the type will be determined during runtime and not during compile time, right? And the inline function here, the inline keyword here means this whole body will be called whenever you call this function. This is just to make it efficient, right? So if we copy the whole of this and we'll paste it here, instead of having this, we'll paste it here. Then this generic type is expecting a Spring Boot application. So we can simply copy this, put it here, and this is fine. And it called class.java by reference here. Then the argument, you pass it here as var args in Kotlin. This is the way you call it in Kotlin, right? And you can simply run this and we're good to go. But before then, let's go back to application properties. We need to bind this to a port. We'll be using port 8080. Right, then I'll take you through the repository class that I've created. Now for repository, I created the level of abstraction here. Then I implemented it here. So I just use an in-memory collection, which is a map. This is just to mimic a database connection, right? You can get all, and this will return all the values of map. Convert this to list, right? And to get, you just get a user from the map. To save, to update, delete, you remove. To check if it exists. If a user exists, it's just to simply check the keys in the map. Now this is the service layer, right? The service layer handles requests from the client. They interact with our DB, which is the repository layer. So it's coming between the endpoint and the repository layer. So I've created basic functions here to call from our endpoint. So you can see get user. So I try to make it flexible and dynamic. So we'll control our data, we'll control our code, HTTP code too, right? So before I explain this fully, if we go back to data transfer object, that is the object that will be transferred from the client to the server and from the server to the client. For requests, we're simply creating a user management endpoint, right? So for this, we'll take ID, first name, last name, age. ID is non-able here because when you make requests to the endpoint, you don't have the ID. It is the server side that will generate the ID for you. So for this, we can have this as null at this point. Then for the response, I have a generic response here. So I try to make it flexible. So we'll be the one to create the code, HTTP code. By default, we have 200 there, which is okay. Then we have message. Then we have data, which is a generic type of T, right? We define that here. Then for converter, we have extension function here that will convert our DTO to model. Then from model to DTO, right? Because data will be transferred from service to the repository using model, and to respond back to the client, we'll be using user data transfer object. That is the DTO here. All right, that's good. Then the next thing here is model, which is the same thing, basically the same thing as data transfer object, right? But for this, we are sure that we have our ID, because this is interacting with our repository class, which encapsulates our database, right? So it's always good to have different layers this way for separation of consign and all. So this is a clean architecture. When you come to your backend, you have to separate your repository layer from your service layer, right? So what we need to create here is our endpoint, which will be controller when it comes to Spring Boot application, right? So I'll create a controller package here. Then I'll create a class. This is a Kotlin class. This will be user controller, right? So we'll normally annotate this with REST controller, right? Then we'll make request mapping. For the request mapping, we have /API/users, right? I always prefer to have it this way, just in case you want to scale up your backend application and you want to break it down into different microservices, right? So we can have something like this. We can also have maybe auths, just like that. So you have different microservices for authorization. Then you have different microservices to manage users, right? Then you can have an API gateway intercepting your requests, so it can be redirected to different microservices, right? So for this, we have it this way. So for us to call our service class, we need a reference to our service class. And creating our service class here, we also need a reference to our repository. So I have it this way: private var user repository. This, which is for user repository, this can be, we have an implementation for that. We have it this way. Then next, we'll create an instance of user service this way. Then user service, this. Then we'll have our repository instance here. Okay, good. So the first endpoint we'll create here is to get all users, right? So this is going to be a function. We'll have it at get users, right? Then this will return, okay, get users, right? Then this will return response entity. Yes, because we want it to be flexible. We want to be the one to define our response code and our body, the data that will be returned back to the client. So we're going to cast this to API, and this is our wrapper, right? Our response wrapper from DTO.response, this, right? Then we'll have this way. Then we need to cast this. This will return list of user DTO. User DTO. Good. All right. So for this, then we need to call our get all users. Let me rename this to get all users. Right. Equate this to, this should be our response. Then we can then return response entity. We define our code, response entity dot status, which is the code, right? Then this will be response dot code. We have our code there. That will take an integer. Then the body. For the body, we'll simply pass this. All right, good. Then we'll annotate this with, this is the get request, which is get mapping. This should give us all our users, right? But then if we want to return list of user transfer objects, then it means we have to remove this body here, API response, remove this here. Then for this, we'll simply get our data here. So let's test this before we even create other endpoint. To test this, I'm going to create an HTTP request file, and I'll make that HTTP client within our application here. Then we'll have it this way. Let me create get, this is to get all users. This is a get request to localhost 8080/API/user. Then we've added our port number. So let's try and run this. Let's run this. Give it some time to run. All right, great. So this is running. You can see it's running on port 8080 HTTP. So let's then call all users. This should return empty array. Yes, okay. This is empty array, right? Okay, good. Now, you see we're just returning list of user data. If we come back to this place, where is our controller? This place. And we'll change this back to what we have initially. Right, let's run this again. This should return the code and the data. Then we'll run this again. Get request. All right, great. You can see the code, message, then empty data. Then let's create another endpoint. This should be post. This should be at post mapping. To add a new user, then we'll have add user. Right, this should return response entity. We'll cast this to API response, and this will return the user with ID at this point, user detail. But then the request body, we can get that with this annotation request. This should be request body, right? Good. Now we have is that user DTO. Great. Then we'll call the service class to create user. We'll pass in the user DTO at this point. Then return the response. This is our response. Then we can simply return res entity, get the status to be response.code, then the body should be response. All right, great. Let's run this and try this again. We come back here, create a different endpoint, and this will be add new user, right? This is a post request. URL to localhost 8080/API/user, and the content type for this is application JSON, right? Then let's have the body here. For the body, we're going to have first name to be Jante, right? Then we have last name, my last name Adebowale. Then at this point we have age. I think we're taking age too. This should be 30. All right, great. So let's try add. All right, great. Can you see we've added successfully? This is the ID. Now it's coming back with ID, but we didn't pass in ID. ID was null when we were making the request here. Then it means when we go back to get user, we should have one user there. Yes, we have one user. Let's add another user. Say Nike Adebowale. This should be 28. Call this to add new user. This has been added with different ID. So if we get all our users at this point, this list of 2 different users, the first one, this, and the second one. So you can see we have different universal ID here. This one is different from this one. All right, so we're good. Next, let's create updates. We can simply copy this for update, right? And this will be put, this will be put, and this will be put mapping. And we have this as update user, put mapping. This will be expecting your ID, the user ID, which is ID at this point. Then we can then call at paths variable to get this ID. This is string, right? Good. Then for this, we have update users. This is expecting us to pass user ID and user DTO, right? At this point, we have user ID. We can change this name to, then we can simply rename this to user ID. We have user ID here, and we're calling update request this. I think we're good at this point. Let's run this and test update. I'll come back to our HTTP client file. Here, if you get all, you should have empty. Then let's add, then we add a new user. Yes, we have one user there. We have another user. We have two users there. Call, we have two different users. They want to update. Let me simply duplicate this. And this will be update user. Yes. And this is put request. For user that want to update, this is the body. We need the ID of the user want to update, which is this, as part parameter here. Then let's update the age to 35. Run this. This has been updated to 35. Now you see the age is 35. If we call all, if we try to get all our users at this point, we'll see that age is now 35 for Nike Adeboale. This will remain the same. Okay, good. So we are done with update 2. Next, let's create. The next thing we want to do is to get a single user. To get a single user, we can simply copy this, paste it here, and this is get request. This will pass in our user ID. We have user ID here. Then at this part here, we should have at parts variable, this ID. Then we have user ID. This is a string. This is expected to return a single user and not a list. So cast this out. Right, simple. Then get user, pass in the user ID at this point. Then we are good. Get request, this. Then the next one will be to delete user. Then this one is get single user. Right, good. Then the next one will be to delete user, which is our last call here. This will be delete mapping. This is a function to delete user, right? And this should take delete user. They should be expecting, and this should return API, no, REST body. Cast this to API response. You are deleting user. Let's check what is the response when you delete user. Update delete user will simply return string that it has been deleted successfully. All right, so we're going to cast this to string. Then the body. Then for the body we have a user.delete. This is expecting user ID. We'll pass it as part here, which is ID. Then we simply have at parts variable ID. Then we have user ID here. Pass it in here, user ID. Simply equate this to response. Right. Then we can simply return this response entity. Define our status to be the integer code, which is code. Then the body simply response. All right, great. So it means, let me format this. So we have our get to get a single user, then we have delete. So we're going to test all the endpoints. I will run this project. Then I go back to HTTP client file. Right, we want to test delete. So I'll simply add this. It has been added. Then I'll add Nike again. It has been added. If I check the list, get all users. Now you see we have all users. Jante, then Nike, Adeboale, the same last name, different IDs. Then we want to test get. We just want to, at this point we want to get a single user. So to get a single user, we'll create a different endpoint for that. Get single user. right? And this is get request. This is a simple get request. API users, then the ID. I want to get this, run this. Great. Can you see we have a single user there, which is just Nike Adibowale. Then delete. We can test our delete here too. This delete user. On delete user, I want to delete this user, but then before we delete, can we make a request to all users? We have it this way. We have Jante, we have Nike. Then for delete user, this will be the endpoint is delete. Let's try it out. Okay, good. Deleted successfully. It means when we make requests back to this to get all, we should have just a single user. Now you can see this is actually straightforward too. We created our controller to interact with our service layer. The service layer will interact with the repository layer. So this is straightforward. The link to this project, the link to the source code will be made available in the description box below, right? So you can try it out and just make it. You can try it out and do something different with it. So the idea is to make our endpoint very dynamic and flexible, so we can define our code on our body, and that's what I'll be able to do in this video, right? So thank you for watching this video. See you some other time. Have a good day.